Thank you so much, Walter. Okay, so I'm just going to assume that everyone can hear me and see my presentation. I have the chat on in a different window. So if I'm talking to myself, just, shout at some point. Otherwise, I will assume that you can all hear and see me. So thanks everyone for coming. Well, not like you came from anywhere, but thanks for tuning in to my talk. I will discuss with you today a case study, which is based on a couple of my clients, 1, 2, maybe 3. And I won't be naming any names, obviously, but I think some of the things that I'll be talking about today will sound familiar to a lot of you. And for those who are not super familiar with this, I hope you have a vivid imagination. So first things first, and I see that my clicker's not working. Dang. Okay, now. So who am I? What am I doing? Why am I talking to you? So my name is Lian Li, and I'm an engineering manager and consultant at Container Solutions. We are a consultancy focused on programmable infrastructure, cloud native transformation. I've been in tech for about a decade. I started out with PHP as a backend dev, then I moved to front end, then full stack, then DevOps. I also dabbled in data engineering for a while, and then moved to Amsterdam finally about 3 years ago to join CS. So what kind of clients am I speaking about? Might be your next question. So since I've so as an engineer, I worked with like smaller companies, mainly like maybe 100 people less. I actually worked with one pretty big organization with about 800 people. But as a consultant, I worked with huge enterprises mainly, and also with enterprises that operate in highly regulated sectors, just like the one that I will introduce. And this one is a stand-in for all the problems that I've encountered, and also a couple of solutions that we suggested. So let's talk about this client that doesn't really exist. It's called MoneyBank, and maybe you can guess what sector this organization operates in. MoneyBank is a huge enterprise with a tech department of around 200 engineers that includes software engineering, operations, office IT, and so on. As it is typical with big enterprises, there are clear hierarchies here, and to some extent also clear role and responsibilities. So I say to some extent because while they are defined and very clear for some people, they usually are not super clear for everyone. But there's a C-level and there's multiple layers of middle management, just as you might know from big organizations. And finally, as you might have guessed, MoneyBank is operating in a highly regulated sector, in fintech. So this is a sector that we have seen explode in the past couple of years. And like more and more companies are moving into fintech or popping up as new fintech startups. And within the engineering department, and I'm now excluding things like office IT, office administration, we will have different product teams. And these product teams develop individual products and features. For example, the software used by tellers, or online banking software used by clients. Then we have service teams. And these teams provide internal services for the product teams. So most notably, this includes operations, because they provide the service and platforms to run those products on. And finally, we have specialized teams. They act as facilitators and internal consultants, but they do not directly contribute to the product pipeline. So an example of that would be the security team, which provides best practices and guidelines to the developers, but they don't directly contribute to the product itself. So this is kind of similar to if you have read team topologies, where they talk about stream-aligned teams and platform teams. And I forget the third one is like complex sub-teams or something like that. So it's kind of that kind of structure. And there is a a separate team that is somewhere in between service and specialized teams. It doesn't really fit this structure, which is QA. So QA, they provide devs with kind of like QA as a service. So they receive something and then they provide kind of assurance of quality. But they also develop best practices, which they will then share with all the developers. So they kind of are both or in between. So when we first met with MoneyBank, their biggest challenge was that the delivery was very slow. And they have identified the issue, which was that a lot of their steps were manual. So I already mentioned QA. So they are somewhat of a service team and so on. And the consequences of the way that QA existed in the structure was that they were a complete black box to anyone outside. So they had their own way of doing things and were completely independent, which was good for them. But the handovers to and from QA were often very laborious and they had to be done manually. Spinning up test environments for QA also had to be done manually, or at least there were like scripts that you had to modify a little bit and then trigger and run manually. And this is also not just for test environment. Also, the staging environment required some manual work to get ready for testing, because sometimes you had to load some specific data from somewhere. Sometimes some configuration had to be changed here and there. And finally, because of compliance reasons, there was a final check that had to be done by all major stakeholders that had also to be done manually. So after we kind of understood their problems, at least on a surface level, we started kind of brainstorming some suggestions. And this is kind of the gist of what we suggested. So for QA, we figured we needed to get QA to automate their tests and also be more transparent about what they're exactly testing. And we could achieve that through automating. There was just no way around it to reduce the cognitive load and the workload for these handovers. If you don't know what they're actually going to test, you can't optimize for that. Also, to quickly spin up test environments, we suggested to move to container orchestration. So something like Kubernetes. This came from a Docker Swarm. So they started with Docker Swarm, so they already had containers. So Kubernetes was kind of like the next logical step from our point of view. And they chose to host their own OpenShift clusters on-prem, so they could guarantee that all data and traffic was kept on-premise in accordance to European data privacy laws. And then finally, to ease auditing, and to give everyone kind of a security blanket, we suggested to go with GitOps as a flavor or a way to implement CICD best practices. So yeah, we came to an agreement with MoneyBank. They liked our suggestions and they hired us to help move their services from Docker Swarm to OpenShift with the new GitOps platform that we were supposed to help build. And luckily, all of this was completely greenfield. The cluster was new, the platform was new, so we had a lot of freedom. So let's talk really briefly about what GitOps actually is, so we're all kind of on the same page here. And I'm sure there are differing interpretations, definitions in the details, but generally in GitOps, you have a Git repository in which you store the configuration of your infrastructure. So not necessarily of the infrastructure itself, so not necessarily how the cluster itself is configured, but the configuration of your application within your infrastructure. So this could be Kubernetes manifest, could be Helm chart, could be a Docker Compose YAML. GitOps does not require Kubernetes. What it does require is that you are able to define the desired state of your application in the environment that you're going to deploy to. And having a repository comes with a lot of perks, like an audit trail or being able to collaborate on integration through things like pull requests. So this repository is connected and synced to an environment in which your application lives. This can be your Kubernetes cluster. It can be something like ECS. Could be just a VM. Again, this is not necessarily your, it doesn't necessarily have to be Kubernetes. But you'll need something that facilitates the deployment of the environments, because all you have is a desired state expressed in some kind of configuration. And you need something that will take that state and make sure to try and sync that to the environment. So in this case, you can, for example, use the Kubernetes API, or you can use a dedicated tool for that. Okay, so to understand the changes that we needed to be made with MoneyBank, let's consider first the starting position. A release or change would always start with the product owner, so PO stands for product owner, requesting a new feature. They would speak directly to the devs or open a ticket in the ticketing system. The devs would pick up that request and implement it, do some local rudimentary testing. Some services do have unit tests and some just didn't. Next, the devs would merge or cherry pick all the changes into one release branch. So they were using Git flow, and this would then be the release package. So then there's a specific role here that is sometimes taken over by the dev team lead or sometimes by the PO. It really depended on the structure of the team and how they worked best. But this release manager will then build the artifacts, so Docker images mainly, and deploy them to their development environment. And here, the devs can do some integration testing in between the services. And finally, when they were happy, they would approve these changes. Then the release manager needs to inform QA. And as I said before, QA does everything kind of in their own way. So they would deploy the changes, take them from the from the release manager, deploy them to the test environment, run their tests, and approve the changes. And then they would inform the release manager again, hey, we tested everything, everything's cool. So the release manager now has to trigger the deployment to staging. Then they have to inform the PO. So the PO can run their own tests and give like final approval. And then the entire changelog, including the references to all the commit hashes, all the artifacts, everything is being sent to the operations team, who then deploy the changes to production. And sometimes things go wrong here because despite all the rigorous testing, production, staging, and test fundamentally differ from each other in the way they are maintained and provisioned. Mainly because of convenience, because if you have so many different ways to do things, you're just going to cut some corners here and there, and then these environments just completely start to diverge. So the first thing we did was we took a look at this middle lane, so the things that the release manager did. There's some stuff in here that's like blue or green that is in itself automated but requires some manual triggering. And this test and approval step is somewhat automated for some services, but not for others. And this is the same for the deployment to staging, which is why they're both kind of this orangey. So since staging is an environment that is shared, a release manager can use an automated process to deploy to it, but then they still need to do some legwork and update some configuration probably to make sure that all services are still talking to each other. Right, so the first thing we tried to do was to take this middle lane, the role of the release manager, and try to have this taken over completely by the system, completely automate everything that happens in there. So we start again with the PO requesting a feature, and the devs would implement it and test it. But now any merge to the release branch would trigger a build step automatically. And then we would build a Docker container again automatically. So yeah, so this meant we weren't cherry picking anymore. We were using mergers. Once the build was done, the deployment to the development environment would also be triggered automatically through the magic of GitOps. And we would create a pull request to our ops repository, which would then automatically be merged. And then we would run our automated tests. So by this point, most of the stuff was already automated, which took some time. When all tests passed, then QA would be notified, again, automatically, that a new release was ready to be tested on their test environment. And they would take over and do their usual flow of deploying, testing, approving manually. And then they had to give approval that the changes were not breaking anything. And the way that they would give approval now was that we were creating pull requests now. And we created a pull request to deploy the changes that we had deployed to dev. We would deploy the same changes to staging. So all the QA had to do was approve that pull request to staging. And once it was approved, once it was deployed, the PO would now receive an automatic notification that the changes are now ready to be tested on staging. And the rest of the process would stay the same. So what's great about this now, this state that we have, is that we managed to abstract the infrastructure in such a way that we could do automated deployments through the GitOps platform already to dev and to staging, and technically to all the environments. But within this process, the deployments were done manually to test and to production. So that's what we focused on next. But first, I want to show you the architecture that we developed. So everything starts with the application repository. From there, a Jenkins pipeline is triggered to do two things. It does more than two things, but this is the two main things. First, we build the artifact and push them to an artifact repository. In this case, we use SonarQube Nexus, and this one, the Nexus lived outside of our clusters. After all the artifacts were in place, we would then submit a change to the config repository, starting with the dev environment. And we created one repository for each environment and for each namespace, which was a business unit. This repository would trigger an Argo CD instance to deploy the resources. So here we're using Argo CD to facilitate the deployments, and Argo works with Helm charts. So Argo would just make sure that the state of the config repository would always be synced with the state of the environment. And then we could just do and this would be an automated sync through webhooks that we used. And technically, this would then work for all the environments up until production. So the actual setup was a bit more complex than this, but it should hopefully give you an idea how the flow looked like. And I see I have to speed up a little bit. Okay, so the thing is then now that if we take a look again at our delivery flow, we can see that the deployment to prod is still being done manually by the ops team. And the reason why is because as owners of the most sacred place, the prod environment, they were personally responsible. So as persons responsible for what happened there. And they said things like, oh, yeah, you know, you have to like sign everything in blood 3 times before things can go to production. So to address this, we automatically created a pull request with the changes between prod and test. And all the ops team had to do was they only needed to approve this pull request and then merge it, and that would trigger the automated deployment through Argo CD again. So it was the same way now that it was working like on dev and on staging. And this took a lot of time and responsibility off their plate. Interestingly enough, we detected less errors in prod instead of more, which has always been a big management concern. And we think it was because the ops team didn't have so much cognitive load anymore that they had to take care of. So next, we took a look at the QA, which owned their own infrastructure, and they had their own development culture and structure and way of doing things, as I said before. And that tended to cause a lot of friction between the product teams and the QA. So QA didn't really belong in the structure that I've shown you with the 3 types of teams, but they were very crucial to the delivery process still. So after a lot of discussions and designing, and we figured there was a solution, but it was a truly radical change. And we weren't sure if the company would go for it, but they did because they wanted radical change. So what we suggested was to eliminate QA completely as a team and as a lane in this process. So how would this work? Obviously, we're not suggesting to eliminate QA entirely from, eliminate quality assurance from this process, but instead, we wanted to embed QA into the development teams so they were truly cross-functional. So the team member responsible for QA would write the test suites already during implementation, and they would still keep in touch with the other former QAs throughout a community of practice. So in this process, everything stays the same up until the devs are done with their preliminary tests on development. And then the test environment now belongs to the dev teams. So that means that they were finally able to do away with all the extra different stuff we needed to do for QA, but could instead standardize the deployment flow throughout all environments. The tests were run and approved automatically because, again, QA was embedded in the development team. And then after the deployment to staging was done, because everything was now triggered and run automatically, the PO would be notified again, there's a test, please go and approve it. There's a version on staging, please go test and approve it. And the rest of the flow stays the same. So at this point, we were with MoneyBank for a year, and development speed did pick up a bit. And developers were much more productive now. They could focus on development instead of merging strategies and all that. Plus, since everyone could deploy at any time, and they did, confidence in the system grew. If you use something twice a day and it only breaks, every 3 months, then you definitely trust it more than something you only use every 3 months and then it breaks, every other time. But there was one thing that was still bugging the engineers, and they had united and picked this new thing to blame, which was that all the changes would go super quickly into staging, and then the deployment to prod still took such a long time. Why? Let's take a look. So there are still some manual steps left in this process. We see them, everything that's not in this blue line. Some are these red ones. They will never be automated as long as the robot uprising hasn't happened yet, because these are manual tasks in their nature. But if you take a look at these other steps, I think there was something we can still do about it. So one of the main reasons why the PO and the ops team still needed to do manual approvals is because they needed to sync with the board and higher level stakeholders about business intention. So something like, hey, do we need to communicate a downtime? What are the risks when we release this? Do we need to, have a press release for the changes or something? On the surface, this seems like these steps are also manual in their nature, but we felt that we were missing something. And in one of our sprint reviews, one of our stakeholders kept pointing out, pull request is not enough. Business people cannot read pull requests. They don't understand. And then we were saying, yes, but they can read Jira tickets. So why don't we mesh this together? So this was the new pattern that we kind of thought of at this point. And I'm sure it's not a new pattern. I'm sure other people have thought of this before, but I also came up with a catchy name. So yes, release ops, the new hot shit is born. Basically, the idea of release ops is just to align what a release means for the business with what a release means for the platform. So I know the time is almost up. I need 2 more minutes. I hope that's okay. All right, so I've moved the swim lanes around a bit to better illustrate what happened here. And if we take a look now at the second lane, this is our newly introduced shiny release ops automation layer. And what it does now is represent the state of a Jira issue. So we start with the PO requesting a feature, but this time they don't message the devs about it. They instead create a Jira issue. They outline the feature request acceptance criteria, and the release gets an identifiable ID. The devs are automatically informed. They implement the request, add comments when they make design decisions, explain their reasoning, and so on. When they're done, they move the issue to the status in deployment, which then automatically merges their feature branch into the main branch. So now we're working trunk-based. So for this to work, everything needs to be integrated. So we use the Atlassian suite for this. We use Jira, we use Bitbucket. Everything just works, integrates well with each other. So why not use it? From there now, we now go to the below swim lane, and this is the same as you've seen before. So the entire process from dev to staging is taken care of automatically. And then instead of notifying the PO directly after things were deployed to staging, our pipeline now instead sets the issue to in review, and assign it to the PO. And yeah, the PO can then test and approve. But then at the same time, the ops team also gets a notification. So they own all the tickets that are in review, and they own the approved column. So they can then say, okay, this is approved now from a technical standpoint. So the ticket is approved as a status, and that will then trigger the deployment to prod. How much time can I still get? Because there are like 3 more slides.
You're already 2 minutes over time. Sorry.
I'm so sorry about this.
It's and I'm letting you talk because it's a super interesting talk. So I'd really like to hear the rest of it, but we have to stick to a schedule. So if you can make final remarks, that'd be great.
So, okay, let me just wrap up. I'm sorry that I didn't get to finish this, but if you want to, I'm going to be in open space number 10, I think, later. So 2 things I have to mention. We are hiring. We're also doing remote work, so you can come and talk to me about our work as a consultant. And the other thing that I wanted to mention is the rise of the internal developer platform, which I think is something that's super interesting in the context of this topic. So I would love to talk to you about that in Open Space 10. And I'm sorry I didn't get to finish, but thanks for listening, and have a great rest of the conference.
Yes. Thank you so much, Lian. I really thought it was a very interesting talk. These kind of different ideas on how to do operations and how to do a development lifecycle are quite interesting. At the same time, we have John Willis with us for the next